Hello guys, it's Johnny time and welcome to another Solidity smart contract hacking and auditing tutorial. Today we're gonna solve the fifth challenge of Damn Vulnerable DeFi, which is one of the best challenges to practice smart contract hacking. The fifth challenge is called the rewarder. We're gonna exploit again flash loans, this time in order to exploit yield farming and reward pools. It's gonna be super interesting and exciting, and I hope you will enjoy it. Now, without further ado, let's get started. So this is the fifth challenge of Damn Vulnerable DeFi, the rewarder. There is a pool offering rewards in tokens every 5 days. So you're probably familiar with PancakeSwap, SushiSwap, all this kind of yield farming that offer rewards. So this is quite similar. They offer the rewards for those who deposit their DVD tokens into it. So like PancakeSwap, when you deposit LP tokens, or in the Zero pools you deposit other tokens, they give you rewards with cake. So this is kind of similar rewarder pool. Alice, Bob, Charlie, and David have already deposited some DVD tokens and have won the rewards. You don't have any DVD tokens, you don't have any tokens to deposit in the pool, but in the upcoming round you must claim most rewards for yourself. Oh, by the way, rumor says a new pool has just landed on mainnet. Isn't it offering DVD tokens in flash loans? Alright, so now we understand that there is some kind of reward pool. We don't willing to get the DVD tokens to deposit, but we have a hint over here that we need to exploit a new flash loan pool, a lending pool that allows us to do flash loans for this kind of DVD tokens. So it's gonna be super interesting. Let's observe first the code. So this challenge includes 4 smart contracts. First is the accounting token. This is a token that will be used. It's not liquid, and it's not token that's supposed to have liquidity, but it's a token that all its purpose is to count how many tokens, DVD tokens, liquidity tokens you deposited to the rewarder pool. That's how they implement it, using this kind of account token. Another contract is the reward token. This is a token that they will use to reward the users by depositing the DVD tokens, which is the liquidity token. So this is, if you're familiar with PancakeSwap or SushiSwap, this is like the sushi or the cake token. Then you have the smart contract for the rewarder pool. This is a smart contract that includes all the logic and functionality to calculate who are the ones who deposit, who are the ones who withdraw, who are the ones who are eligible for the rewards, and it's probably also includes the external functions for depositing, withdraw, and collecting rewards from the pool. Then we have the one that they talk about, the flash loan pool, which offers DVD tokens, the so-called liquidity tokens that probably will need to but use it in order to exploit the rewarder pool. So now that we went through the smart contracts and we understand all the architecture and how it works with each other, let's jump into the JavaScript file, the test file. As you can see over here, there are 1 million DVD tokens in the lender pool. It's a variable that is being set on the beginning, and then you have all the setup over here. So there are plenty of signers because there are multiple users, and then these are all the contract factories. You can see, even though we saw 4 contracts, we can see that there are 5 factories because there is another one for Damn Valuable token, which is the liquidity token, the one that you need to deposit in the reward pool in order to gain your rewards. Then you have all the deployments of the smart contracts, some transfers, some deposits from the users. So all the users deposit 100 DVD tokens in order to gain those rewards. Then there are some tests over here that everything behaves as expected. Then there is this kind of line of code that basically tells the EVM, the hardest blockchain, local blockchain, to move forward 5 days in time. So to simulate like 5 days were passed, so the users can withdraw the rewards. And eventually you can see here that there are some tests that the users can withdraw and claim the rewards, and that the rewards that they get are actually correct compared to the total supply. Then we make sure that the attacker has 0 DVD tokens, and the round number, the snapshot is 2. Here we have to implement our exploit, and eventually we need to make sure it checks that the round number is 3, that the users can get rewards, and of course the attacker also gains some rewards even though we don't have any DVD tokens. So in the beginning we don't have any DVD tokens. We need somehow to find our way, probably use the flash loan to borrow the DVD tokens, deposit, and then exploit it to gain some of the rewards. So it's going to be super interesting. All right, so always before implementing the exploit, it's better to plan it out, to plan the whole exploitation, the whole vulnerability process, and that's what we're going to do right now. So the first step, we already have the solution in mind, and if you want to try to think about a solution yourself and try to solve it yourself, you can pause this video. I highly recommend you to try and going through this challenge yourself and then checking out the video to make sure that you did it correctly. But first we have to plan our attack. So our attack gonna be, we're gonna borrow this liquidity DVD tokens from the flash loaner tool. So we're gonna write it by steps. So first we want to borrow DVD tokens as much as we can. Don't forget that we have to pay it back on the same transaction because it's a flash loan. Then the second step would be deposit the tokens to the pool. Okay, we want to deposit the pool. Okay, then we want to wait 5 days, but in our terms we're not going to actually wait 5 days. We're going to move fast forward the chain because we can simulate it. So we're going to wait 5 days. Okay, once we waited 5 days, we want to to harvest, to claim our rewards. So claim rewards, the reward token. Then what do? Withdraw. Okay, we don't care. We don't want to leave the funds in the contract. We just want to withdraw the tokens and send them back into the flash loaner pool. So withdraw the rewards and pay back the loan. So eventually, after we completed all these kind of steps, we're supposed to get the reward tokens, even though we don't know any DVD tokens. We just exploited a flash loan opportunity to manipulate the reward pool. Guys, I wanted to share with you something super exciting and new. I've created a complete practical smart contract hacking course accumulating 12 years of my cybersecurity and blockchain experience. Without exaggerating, this is your holy grail all-in-one course which will instantly help you kickstart your career in smart contract hacking and security, making you the most demanded professional with insanely high salaries. Get exposed to tons of knowledge by signing up in the description below. And now it's time for implementation. We're gonna start by implementing the smart contracts. We have to implement a smart contract in this kind of exercise because the flash loan actually is calling receive flash loan function, and we need to implement this function in order to receive the funds from the flash loan. So we have to write a smart contract. So we'll go to the folder and we will create a new file. We'll call it rewarder, and then we're gonna copy some lines of code, the Solidity version. Rewarder, attacker. All right, so now we need to think whom the rewarder attacker is gonna communicate during the attack. So obviously we want to communicate with the flash loan pool because we want to execute a flash loan. Then we want to communicate with the reward pool because we want to deposit and withdraw tokens and accumulate our reward token. And obviously we want to interact with ERC20 tokens. So we need to write all these kind of interfaces so our smart contract will know how to access this function. So first we're gonna import the interface for ERC20 tokens. So this kind of OpenZeppelin interface will help us to do everything that we want with ERC20 tokens. And then we want to implement our own interface for the pool. It will make sense, okay? And in the flash loan pool, we have only one function actually that we want to write the interface, which is the flash loan. So we're gonna copy it over here, and this is our interface. Quite simple. This is how we communicate with the flash loan. Then we want to create another interface with the reward pool, right? Because we want to interact with the reward pool, and in that case we want to interact with multiple functions. First of all, we want to deposit funds, so this is one of the functions. Then we want to withdraw funds eventually, right? Because remember, we already planned. Once you plan your attack, it's going to be much easier to implement the exploitation. So always start with planning. Then we want to call the distribute rewards function. because we wanna distribute the rewards eventually. And that's basically it. This is private function. So these are the functions that we want to implement in our interfaces. Let's change it to external so Solidity won't scream at me. Now we just want to jump into the reward or pool smart contract and make sure that our assumptions that it's manipulative and we can actually hack it are correct. So this is the deposit function. You see it's quite straightforward. We send it amount to deposit, how much we want to deposit. Then it's gonna mint for us the accounting token, the snapshot token that is tracking who deposited how much and when, and it's gonna mint it for us. Then it's gonna transfer from the liquidity token, the DVD token, from our address to the smart contract. Obviously, this is the deposit, and the withdraw is just the opposite. Okay, so it's gonna burn the liquidity token, the accountant token, sorry, and then it's gonna transfer back from the smart contract to ourselves, the liquidity token, the deposited token. Now, the distributed rewards is some kind of fancy math here, very simple, very straightforward. So it's gonna take the total deposits by checking the total supply of the account token and our balance, the user balance that's called this function, and then check basically the ratio of how much we deposit compared to the actual total supply of the accounting token. That's how it calculates the rewards, and eventually it's gonna return the rewards for us and mint it for us. Where it's gonna mint it? Here, over here. So here it's gonna mint the rewards and send us this kind of newly minted reward token, same as cake and syrup or sushi or whatever, all these kind of reward yield farming tokens. So that's quite obvious, quite straightforward, quite easy. Now let's go back to implementing our attack. So let's start by basically declaring all our variables. The first one will be address, attacker address who deploys the smart contract. Then we will have IRC20 private immutable, and we'll call it the token. So this is the token that we're gonna borrow and deposit in the pool. Then we have another IRC20 private immutable, and we'll call it reward token because eventually we want to send the rewards that we claim to the attacker who deployed the smart contract. Then we want to declare the pool and the flash pool smart contract. So we'll do iFlashPool. Then we'll declare iRewardPool private immutable. Thanks for the autocorrection. That's it. We declared all the variables, and now it's time to write the constructor. So constructor, and the constructor needs to get some variables. So it will get the address of the reward pool. It will get the address of the lending pool and the tokens. Okay, so when we have the pools, we want also the tokens. So it will be address and address rewards. All right, now we need to set up all our objects. So we'll do liquidity tokens equal IRC20 to liquidity. And don't forget the attacker is equals message.sender, the one who deployed the smart contract. Now that we finished the constructor, let's define the attack function. All right, so first of all, to initiate the attack, we want to borrow all the tokens from the DVD tokens. That's why we want to check how many DVD tokens, liquidity tokens, the pool has. Are we gonna do it with a balance of ERC22 function? So uint balance equals liquidity token dot balance of, and we want the lending pool address. So we're going to do address lending pool. Very easy. We have already the interface for the balance of, so it's not supposed to be a problem. And then we want to initiate the flash loan. So we're going to do pool. It's going to be lending pool dot flash loan with all the balance. All right, now the flow is gonna be like this. We're gonna call the attack function, which will gonna trigger the flash loan with all the balance that the pool has. And then the flash loan or pool is gonna call our function that we need to implement over here. It's called receive flash loan, and it gets unsigned integer 256 bits. We want to implement it. Let's do it. So let's just copy this and function. Receive flash loan, we'll call it amount, and it's going to be public function because the smart contract, the pool, the flash loan pool need to call this function. All right, now we need to implement all the other functionality. So going back, we borrow the DVD tokens and we want to deposit the tokens to the pool, right? This is going back to our plan and seeing what we planned. So we're gonna do pool, it's not just pool, it's gonna be reward pool dot deposit, and we're gonna deposit all the amount. Quite easy, right? Then when we plan it correctly, everything gets much easier. But bear in mind, another thing that we missed is over here. So here in the deposit function, the liquidity token use the transfer form, which means that it needs to have an approval. We need to approve the reward pool smart contract to spend our DVD liquidity pool token. So first of all, we need to call this kind of approval function. So we're going to do liquidity token dot approve. So first we are approving the reward pool to spend our liquidity token smart contract. So this kind of function transfer form will succeed. Now we can call the deposit function. Now, after we deposited the tokens, it's time to claim our rewards, okay? Because we deposit 1 million DVD tokens, we probably get high rewards due to this calculation. So we want to make sure to call this function so this functionality will be executed. So reward pool dot distribute rewards. Then we want to withdraw it, right? We don't want to leave it there. So reward and the same amount we want to withdraw. Then we want to pay back the flash loan. So we want to transfer all the DVD tokens to the flash loaner pool smart contract. So we're going to do liquidity token because we got it already. The withdraw, we got the tokens. Now, after the distribute rewards function was executed, it's supposed to mint the reward tokens to this smart contract. But remember, we want to send it to the initial attacker that deployed the smart contract. We don't want the tokens to be stuck in the smart contract. So we're going to check how many reward tokens this smart contract has and then send it to the attacker. So we'll do uint tokens equals reward token and address this. So this is the balance of the tokens that we have, and we want to transfer them to the attacker who deployed the smart contract. So we're going to do reward, and the amount will be the tokens. Okay, so all the reward tokens eventually will be transferred to the attacker. Quite simple, not much stuff. We just implemented all the planning that we've done before. So we have the approval, we have the deposit, distribute rewards, withdraw, transferring back the liquidity tokens, the DVD tokens to the flash loan pool, then getting how much rewards we got and sending all to the attacker. Very, very easy. Now it's time to deploy the smart contract and execute the attack in the JavaScript file. So we want to do two simple things. One is move the EVM 5 days, so it will simulate 5 days having passed since the last reward period. Then we want to deploy our smart contract attacker and then execute the attack function, and eventually the attacker will have all the reward tokens, and these tests supposed to be correct. So let's start by shifting the EVM 5 days forward, advance in time. We're gonna do just copy this kind of line of code. Then we want to deploy the attacker smart contract. So we're gonna take the factory first, but we'll call it, this is the name of the smart contract. Then we want to deploy it, so we'll call the deploy function. We'll call it const attacker contract, and it will be the factory.deploy, but this time we need to pass 4 parameters because these are the ones that we declared in the constructor. Let's get it over here. We have to pass the reward pool, the landing pool, the liquidity token, and the reward token. So the reward pool is going to be this dot. That's it. Once we deploy the smart contract, we want to call the attack function and everything's supposed to work. So let's do await attacker contract. Alright guys, so I had some bugs. First of all, I deployed the attacking contract from deployer instead of attacker. So it made some problems because here the attacker wasn't the attacker address but the deployer address. Also, it doesn't need to be payable because we are not dealing with ETH transfer but only with ERC20 tokens. And also I had here address, and I don't need to do that because it's already an address. So I fixed all these bugs, and now let's try to run the code and hopefully it will work out. So yarn the rewarder. Perfect. Now it works. I also did some debugging. By the way, a very nice tip is you can import the Harriet console and then you can use console log inside the smart contracts. I just print this kind of debug over here so I can make sure that I actually got the reward tokens and the attack actually worked. And then eventually I understood it worked, but there was a problem with the attacker address. That's how I found the bug. So just another tip for me to you of debugging Solidity code. Thank you so much. I hope you guys learned something new from this video and it helped you out. If you have any questions, feel free to ask them in the comments below. And if you like the video, make sure to leave the like button and subscribe to the channel. Thank you, and I will see you in the next videos. Bye bye.